Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Last episode we drew Duke to the screen and animated his walk cycle, so today we will animate the flasher tiles, such as for example the blinking lights and the wall panels. We'll also make our camera follow Duke around a bit more smoothly than it's currently doing. But first though, we'll take some time to analyze the border tile set, and then drawing in the border in order to really bring the graphics together. Alright, so let's begin by dumping out the border file. So let's make a throwaway method where we'll just read in the file. Border retiles border.dn1 and we'll dump it to a single image and then we'll see how they are laid out, just like we did with Duke. So we'll have border.size times 16 type, and then let's write it to a PNG file. Okay, import, this throws an exception. Let's loop across each border type, border size, image, get graphics, draw image, border, get I times 16, 0, null. All right, so this should write out the border file. And here we have it. All right, let's take a look. So here we have the individual border tiles. And here we have the tiles that you see with the text boxes. We got some labels for our borders. Health flashes red when we're low on health, I suppose. Got some unused graphics there. Not too sure what this SF and these P and R mean, but I guess they represent some sort of state in the game, so we'll need to figure that out later. Okay, so let's start by making a new class for this heads-up display. So let's just call it HUD. And let's give it an instance to the, or a handle, I guess, to the resource loader. And let's pass it in a constructor. And then let's give it a init method like everything else. So this class is interested in the border images. And here in the init borders is loader.getBorder or read border. Okay, this doesn't exist yet, so but it will be the same as the read tiles and read man, with the main difference that it just has one file, border.dn1, and it has to be opaque, and return. Okay, so now the HUD has a handle to these tiles. Then let's make a public void draw that takes in the game state. And it takes in the graphics to draw to. Okay, so let's take a look at our border file one more time. And so what we need to do is we need to get each single individual tile and we need to place it at the correct spot. It's going to be a long, tedious, and pretty boring video to look at. So what I think I'll do is I'll just type everything in, but I'll just make it sped up quite a bit so it doesn't waste your entire afternoon watching this video. So let's go ahead and do it. Okay, so let's see if this HUD is going to work. So let's add it here, private HUD, and let's make a new HUD with our resource loader, and then initialize it to make sure it loads up the tiles that it needs. And then here, after we've done drawing everything, we can tell the HUD to draw itself based on the game state with the graphics. Okay, so let's check it out. Okay, and here we can see the HUD nice and well in place. It really ties the game together because now we do not see those the tiles on the edges of the screen, coming in and out of view. So that's pretty cool. One thing that we do have now is that our background graphic needs to shift to the down and to the right. So let's go ahead and do that real quick. Background, backdrop. So all we have to do is just tell it to render itself at the 1616 coordinate. All right. So what we'll do now is we'll animate the flashing tiles that we have in the background. So the original Duke Nukem game has some flashers, they call it. Let's open up the shikari.net webpage, and so let's drag it into the screen. Here it is. Let's go to the level format here, and here we can see that the first range of hexadecimal numbers all the way up to 0600 are flashers that are animated backgrounds or stationary backdrops. So that's pretty nice. So the backdrop is something we already have. So all we need to do is animate all the tiles that are beneath 0600. So we can do that right here. So let's get our tile index here, and then let's check this out. Okay. The index is tile ID 32 plus tile ID less than 0600. Then we need to add our flasher count, or otherwise we can just keep the index. So flasher, let's create a field. This is going to be a global counter that will just update the animation frame for each flasher in the level. So normally what you would do in Java if you want to do correct object-oriented design is like design a tile and then extend it for animated tiles, and then let's keep, each animated tile is going to have its own counter for which frame it's supposed to be on. But in Duke Nukem, all these background images, I think, are all controlled by one and the same animation counter. So that's why I'm just going to do it globally in our graphics component, because I think we can get away with it. So let's add the flasher here. Flasher equals flasher plus 1, and we need to make sure we do not exceed 4, because every flasher only has 4 animation frames. So here, grab the tile index based on the tile ID, and if the tile ID is a flasher, then offset it by its animation count. Okay, so let's hit play and let's see if this works. So now we can see the panel in the wall here going about whizzing, doing its thing. We got some lights flashing down here, looking pretty amazing. Got a computer printing all kinds of numbers. And I think to the left here is going to be some more animated graphics with some high voltage. There we go. So that's looking pretty good. So I think we have time for one more thing, and that is the camera. In the original Duke Nukem game, the camera follows Duke around, but it doesn't lock into Duke as it does now. Like if we move 1 pixel to the left, then the camera is also going to move 1 pixel to the left with us. So it's locked in with Duke's X and Y position, and we want to make it a bit more dynamic than that. So let's go ahead and let's do that. So yeah, well, let's keep a camera X and Y position inside of our GFX class, camera Y. And let's remove it from the game state, because we do not need it here anymore. And let's then replace every instance of GameState.getCameraX. Let's replace that with camera X. And then let's do the same for camera Y. Let's replace that with camera Y. Okay. then the camera X and Y position need to be updated as part of the render function. So let's make a move camera based on game state. And then let's say for now, let's do game state, get Duke, get X, and then let's assign Duke here. Oh, Duke. And then camera X is Duke X. Camera Y is Duke Y. Okay, so I expect Duke to be at the top left now. So that's step one. So now that we have Duke clamped to the top left corner, let's do horizontal camera movement first. So let's say let's calculate the screen X coordinate. The screen X coordinate is Duke X minus camera X. If the screen X is less than a certain left boundary, so let's take, I don't know, 88 pixels, then the camera X should become the Duke X minus the 88. And the same should go for the right side. So otherwise, if screen X exceeds the right bound of 120, because we're going to have 32 pixels of wiggle room, the camera X should be updated accordingly as well. All right, we'll assign some variables for those magic values. Okay, but now we can see the Duke is at the very top, of course, but we can see we can wiggle about a little bit before the game starts to move the camera with Duke. So that's looking pretty good. And then we'll do the same for the Y camera. So let's calculate screen Y is Duke get Y minus camera Y. And then if we exceed the top, that's like 48 pixels, I'm guessing, then we need to set the camera Y to Duke Y minus that 48. And otherwise, if we go down too far, screen Y, if we exceed the lower bound, then update the camera directly with that lower bound, so we never go out of bounds. So this will cause Duke to fall down, and then when we jump and go up too high, the camera will follow Duke, and if we go too low, the camera will also follow Duke, so that's nice. The same goes for going left and going right. I'm not sure if these values are 100% correct. We'll validate them later when we play the game and compare our game to the game. For now, I'm pretty happy with these values. So there's one last thing for the camera that we can do, because in the original game, when Duke jumps up on a platform, the camera centers vertically around his position in a nice animated way. So we'll do that here as well. So we can do that if we're not jumping or falling. So let's say if Duke is standing, or if Duke is walking, then we should update the camera Y in the correct position going towards the center. Now the vertical center of the screen is like 6 times 16, which is 96. So move cam to 96. And how we will do that is because we need to go either up or down. So let's calculate the sign of the direction that we need to go. So we need to either go up or we need to either go down, depending on Duke's position compared to the camera position compared to the center. So how we will do that is by taking Duke's Y position, or I guess our screen Y position, and then we'll subtract the center of the stage from our screen Y position. No, I shouldn't do this. I should do the camera Y, I'm guessing. Yeah, so let's just do duke.getY and let's subtract our camera because we were calculating a camera position here. So let's be sure that we have that. And then let's subtract the center from it. So this will tell us if we are above or below the center. And then all we have to do is add to our camera Y 16 because we want to move 16 pixels at a time, and then let's multiply it by the sign so that we're going either up if we're negative or down if we're positive. Okay, so let's see if this will automatically move our camera once we're landed. So let's jump up and the camera follows us around pretty nicely. So again, I'm not sure if these values that we're having, if those are 100% correct, but I'm pretty happy with how they are looking. So I think that'll do it for this episode. If you have any questions or remarks, feel free to put them in the comments below. Feel free to join me again next time where we will probably flesh out the rest of the level, or maybe not all of it, but at least like try to fill in some of these blanks here. Like for example, here we're expecting a window, and then up here we're expecting an Acme sign. And I think we'll also try to do more of the display functions here to the right where we will display the score. So we need to parse the font, and we'll probably display the current health as well so that we can see how we're doing. But for now, that's it. So thank you very much and see you guys next time. Bye-bye.